Hello everyone. What is a quadrilateral? Well, a quadrilateral is a closed figure with four sides. Now in this video we are going to look at what are the various types of quadrilaterals and the formulas to calculate the areas of respective quadrilaterals. So let us first look at what are the various types of common quadrilaterals. The first one is square. Well, a square is a quadrilateral which has four sides which are of same length, and all of the angles are of 90 degree. Now a rectangle is similar to a square, but in a rectangle opposite sides are of same length and the angles are of course 90 degrees. A rhombus is a little bit different. It is similar to a square in the sense that the sides are of equal length, but the angles are not of 90 degrees. In fact, opposite angles are of equal value, right? Now coming to parallelogram, it is similar to a rectangle. We have the opposite sides as parallel to each other. And again, the opposite sides are of same length. But the difference is that the angles are not of 90 degrees. But the opposite angles are equal to each other. Okay? Now, in fact, a square is a special type of rhombus and a rectangle is a special type of parallelograms, because square satisfies the definition of a rhombus and a rectangle satisfies the definition of a parallelogram. Now another type of quadrilateral is there which is called a trapezium. Now in this, only two of the sides are parallel to each other. See, these two sides are parallel, other two sides are not parallel to each other, and the sides may or may not be of equal length. Okay? Now let us look at the formulas to calculate the area of each of these figures. Let us start off with a square. So the area of a square is equal to the square of the length of its side. Okay? So let us find out the area of this square. The side is given as 5 centimeter. So the area of this square will be equals to 5 square, and that will be equals to 25 square centimeter or centimeter square. Easy, isn't it? Let us move on to a rectangle. So the area of a rectangle is just the product of its length and breadth. So the area of this rectangle given here will be 3 times 4, right? So it will be 3 4s are 12 square centimeter. This one's also easy. Let us move on to a parallelogram. The area of a parallelogram is the product of its base and height. Now the base is the length of one of the parallel sides, and you need the height of the parallelogram. So here the base is of 5 centimeter and the height is of 3 centimeter. So this will be 5 times 3, and that will be 15 square centimeter. Okay? Let us move on to the next one. We have a rhombus. So the area of a rhombus will be half into the product of its diagonals. Well, what are diagonals? The lines connecting the opposite vertices are the diagonals. So the area of this rhombus will be half into the length of AC times the length of BD. And we have been given that AC is 2 and BD is 4. So half into 2 into 4. And that will be equals to 4 centimeter square. Easy, right? Let's move ahead. What is the area of a trapezium? Now this one's a bit complicated formula. We have half into the sum of parallel sides into the distance between the parallel sides. Now what are the parallel sides in this trapezium? Oh, let us name this first: A, B, C and D. Now AB and CD are the parallel sides. So we have to first take the sum of the lengths of the parallel sides. So let us do that. That's half into sum of the parallel sides is AB plus CD, and that will be 2 plus 3 times the distance between the parallel sides, and that's 2 in this trapezium. So times 2. This gets cancelled out. What we have is 1 into 2 plus 3 is 5 into 1. That's 5 centimeter square. Okay, so the formulas are very easy. Let us put them to test by solving this question. What is the area of this composite figure? Now this composite figure is basically a trapezium, but we'll try to solve it traditionally. So this composite figure contains a rectangle and a triangle. Okay, so what will be the area of this figure? Well, it will be the addition of the area of this rectangle and the area of this triangle. Okay, so first let us calculate the area of this rectangle. So A1 is equals to, area of a rectangle is length into breadth, and that's 5 times 4, and that will be 20. We don't have the units, so 20 square units. Now we need to calculate the area of a triangle. Now the area of a triangle is equal to half into base into height. Now we have this as a right angled triangle, so the perpendicular side will be the height of this triangle, right? And that is 4. Okay, now we need the length of the base first before we calculate the area. Now being a right angled triangle, we can apply Pythagoras theorem. Now if you don't know what is a Pythagoras theorem, let me write the formula of Pythagoras theorem for you. So hypotenuse square is base square plus height square. Now hypotenuse is the largest side of a right angle triangle, and it is 5. So 5 square is equals to, the base is what we have to find, so x square plus height square, that's 4 square. So this is 25 minus 4 square is 16 is equals to x square. 9 is equals to x square, therefore x is equals to root of 9, and that is 3. Now the base is 3 units. We can calculate the area of this triangle. So area of this triangle is equals to half into base into height. So base is 3 into height is 4. So 2 times 2 is 4. A2 is equals to 3 times 2 is 6 square units. Now we have to calculate the area of this composite figure. So A is equals to A1 plus A2, and we have A1 as 20 plus A2 as 6, and that's 26 square units.